Okay, this is Algebra 2, Day 39. Sorry I can't be in class today, but I thought I'd record a video to help you through your work today. Now, yesterday I introduced a series of practice problems and solutions that I said you'd be quizzed over by the end of the week, and it was your job to establish rules or steps or procedures to learn how to solve quadratic equations by factoring. We're not using any other method other than factoring right now. So you've got to come up with some rules that'll make that work. Now, yesterday you were just using PhotoMath or some website to help you kind of see how solutions were obtained. And today your objective is to write down your list of rules or steps. And these rules, these steps, should be good enough so that they can be used on any problem that can be solved by factoring. I want you to be able to memorize these rules that you come up with so that on our quiz Thursday you could complete the quiz without any reference material. Now, I made the suggestion in class yesterday that your rules shouldn't be all that extensive. I would say 3 to 5 steps should be sufficient. Now, if you have more than that and you've got to memorize, that's perfectly fine. But in all honesty, the rules for solving quadratic equations by factoring shouldn't be too extensive. 3 to 5 steps should be sufficient. What I'm going to do in this video is complete several practice problems from yesterday, and I'm just going to show you how I complete these problems, and I'll let you decide if the rules you began to establish fit the procedure that I'm describing. And then towards the end of the video I'll talk a little bit about word problems, how we can use solving quadratic equations in an applied sense. So here we go. In the first 4 I said that these are the easy kind. If I were to see a quadratic equation written this way, I would solve it by doing this first. I'd write 5v plus 3 equals 0 and v plus 3 equals 0, and from here I would note that 5v is equal to negative 3 because I subtracted 3 from both sides, and now I would say that v by itself is negative 3 divided by 5. That's one of my answers. Over here, after subtracting 3 from both sides, I would note that v is equal to negative 3, and since I have v by itself, I know that that's one of my solutions. And these are the 2 answers to problem number 2. Now, I like writing my answers like this. V equals negative 3/5 and v equals negative 3. However, it is pretty common to see an answer written this way as well. We'll write both answers together inside of a pair of braces. And I believe this is how our answer key from yesterday displayed their results. Except I believe they left off the v equals part. I like having it there. I like describing the variable in question. For number 4, since I've seen these enough now, I'm going to just jump straight to the answer. I'm going to say that p is equal to negative 3 and p is equal to negative 1. Now, I've seen these enough to know that those are the 2 answers. Have you seen enough to establish that so far? What if you take a quadratic equation like number 6? Could you turn it into a factored form like this? Because evidently, if we can get to a factored form like number 4, then we can just jump straight to the answers without showing any work. Well, in number 6, I'm going to factor this using a GCF, and I'm going to note that x times x plus 3 is the factored form of question number 6. And if I, with my experience, see x times the quantity of x plus 3, I'm going to say that my solutions are 0 and negative 3. Now, sometimes you'll see the word or in between these, and sometimes you won't see any words at all. So I'm going to leave those out. I believe our answer key may have listed the answers like this. And that would be fine as well. For number 8, the first thing that I'm going to do is subtract 3n from both sides. We'll call this n squared minus 3n equals negative 2. Then I will add 2 to both sides so that I have n squared minus 3n plus 2 equals 0. Now I'll turn this trinomial on the left, which appears to be a standard trinomial, into n and n, 2 and 1, negative 2, negative 1. And having seen these enough, I'm going to jump to my solution and call this n equals 1 and n equals 2. Those are my two answers to problem number 8. Are you seeing the pattern? Do you have a set of rules or techniques that would work? Let's try number 10. This time I'm going to subtract 5m from both sides. We'll call this 15m squared minus 99m minus 168 equals 0. Now I have a hunch, and I've got my calculator on the screen to check this, but I think 3 acts as a GCF in this case. So if that's the case, let's see, 15 divided by 3 leaves me with 5m squared. 99 divided by 3 leaves me with 33m, and this is the one I have to check. 168 divided by 3 is good. It's 56. It's a whole number. Even though I'm left with a non-standard trinomial, my a and c values are much smaller. My a value of 5 and the c value of 56 are much smaller than 15 and 168, so that should make factoring a little bit easier. And here's a word to the wise. If I give you these problems in a factoring context, then yes, they should factor. So I'm thinking of my factors of 5, which are 1 and 5. I'm thinking of my factors of 56, which are 1 and 56, 2 and 28. Let's see, I don't think 3 is going to work, but 4 times 14 works. 5, 6 doesn't work, but 7 times 8 does. Now I was able to come up with that list in my head because I'm very familiar with our times tables. If you need a computer or calculator to come up with that list, that would be fine. Keep in mind of our techniques from the weeks past, I'm going to start with this pair of numbers and work my way up. And, well, this is the only pair over here on the left-hand side. So I can commit to 5m and 1m as being parts of our factor group. But I'm going to guess that 8 and 7 are the pair that I want here. So to verify whether that's the pair that I want, I'm going to think about the outside product, which is 35m, and the inside product, which is 8m. Can 35 and 8 combine to make negative 33? And I can't think of a way to make that happen, so I don't think that was a good choice. So I removed the 7 and 8 to make a new guess, and instead of throwing out 7 and 8 entirely, I'm just going to switch their positions. I'm going to move 7 here and 8 here. This time my outer products make 40m and my inner product makes 7m. Is it possible for 40 and 7 to combine to make negative 33? Well, that answer is yes. If I have a negative 40 plus 7, that should lead me to a negative 33. And so my last question that I'm asking myself is, well, how do I get to a negative 40 with what I have in front of me? And that would take a negative 8 times 5m and a positive 7 times 1m. And this looks like the factored pair that I'm after. So I'm going to slide over here off to the side. And again, I've seen enough of these to recognize that if I have a factored group, then I know that 5m plus 7 should equal 0, produces one answer, and m minus 8 must equal 0. That produces another. So in this case, m would be equal to 8 after I add 8 to both sides. And in this case, after I subtract 7, I'm left with 5m equals negative 7. And m by itself is negative 7 divided by 5 after I divide both sides by 5. And these are my two solutions. So I'm going to wrap up this video by sharing with you my 3 steps. Here we go. If I were to solve a quadratic equation by factoring, these are the 3 steps that I would go through. Number 1, combine like terms and move all terms to one side of the equation if I can. Now, in the first group up here, I ended up not doing that, and you'll see why. Because my second step of the equation was to factor using appropriate techniques. And in problems 1 through 4, my quadratic equations were already factored. So I didn't even have to go through step number 1 because right at the beginning, our problems are set up to look like step number 2. Now, on the other hand, problems like what was it, 6, 7, 8, 5, I did have to combine like terms and move everything to one side of the equation. So I did a couple steps trying to complete rule number 2, but this is where I'm at after rule number 2 is complete. I have all terms combined and they're on the same side of the equation. Same thing over here. With a little bit of math, a little bit of algebra, I've gotten all of my terms together on one side of the equation. So step 1, combine like terms, move them to one side of the equation. Step 2, start factoring. Sorry, I think I was labeling that incorrectly. This was step 1, all terms on one side. This was step 1, all terms on one side. But then the factoring, the skills that we practiced all throughout the first quarter, that's my step number 2. The skills, or the techniques I should say, that were appropriate in order to factor, that was used here in step number 2. And then finally in step 3, once I have each side factored, we set each of those factors equal to the number 0. Set each factor equal to 0. Now I did that all over the place, sometimes mentally and sometimes by actually writing it out. But in every case I'm setting the factors equal to 0. 5v plus 3 equals 0, v plus 3 equals 0. And I can solve each of those individual equations. The reason why we set these factors equal to 0 is because of the zero product property. And if that's not clear to you following our discussion from yesterday, please take some time right now and search that on the internet, or better yet, find some other YouTube videos that help describe the zero product property. That'll help you better understand how to solve quadratic equations by factoring. So I hope that helps. If you've got any questions, make sure you write those down and talk to me tomorrow when I see you. The goal for tomorrow is to use the methods that you've established, or use the methods that I've shared with you today, and practice with new problems that I hand out tomorrow. Good luck.